All right. Good morning, everybody.
Morning, James.
What? That's great. The coffee's working. Awesome. The sun's not working, unfortunately, but the coffee is. Yeah. I heard a new term yesterday for the marine layer in August. It's called Fogust. So there's a term for every month now here, I guess. Good morning. Welcome to Ag Plastics Recycling in Action, from strategy to operational success. And I'm James duBois. I'm with Driscolls. I lead our environmental efforts in the U.S., Baja, and Canada, and honored to be here and to moderate this wonderful panel here. So I'm going to tell you a little bit about Driscolls and why we're here, our efforts. So we're deeply involved in advancing ag plastics recycling. We've convened industry groups, pilot programs, funded pilots in multiple districts: Oxnard, Santa Maria, Watsonville in California, Florida, Mexico. So it's something that we're very passionate about. It's part of our, it's one of our main environmental initiatives. We've seen firsthand the challenges of mulch retrievability, the economics of recycling when you compare it to landfill, the importance of collaboration across growers, manufacturers, vendors, everybody, right? That collaboration is super important. So today's speakers are going to bring some critical perspectives on mechanical removal, material logistics and collection, pre-processing, and ultimately recycling strategies and recycling processes. You'll hear operational insights that align closely with our ongoing efforts and goals, and to increase the adoption of recycling in our grower group, and to ultimately recycle more of these films. So we'll hear from Ben Andros on mechanical removal innovations, Theron Smith on logistics and pre-processing, Ishmael Rodriguez on operational facility insights. So the format we're going to do today is a little bit different than what you've been seeing. We're going to do, each individual presenter will present 10-15 minutes, and then we'll actually do questions within each of those panels, and then we'll have a general Q&A session at the end. But before I turn it over to the panelists, I'm going to say a few more words about and frame the problem, at least from the Driscolls' perspective. So what are the different field plastic applications that we as Driscolls and our growers experience? Where do these plastics get used? What are the benefits? So I'll start from the upper left. If you drive by any berry production area in California or Mexico, you're going to see some of these greenhouse-like structures. They're sort of a temporary greenhouse. We call them high tunnels. That's a clear film that we use quite a bit of. And all the berries, really, except strawberries in some areas. We use drip tape, which you can't see here, but it's under the bed mulch here. When we, of course, use bed mulch, which is going to be the primary focus of these presentations. We also use fumigation film. Now, that varies year by year, depending on how many growers are flat fuming, what their needs are. At times, growers fumigate under the actual bed mulch. We also use, this is a growing production system for Driscolls. We use pots in these container-grown systems, substrate, formerly called hydroponics, not true hydroponics, in which we grow raspberries, blackberries, blueberries in container growing systems. So we have these pots here, and we also need end-of-life solutions for this. Ultimately, we have weed mat, we have drip stakes and emitters. So we have a lot of very different and diverse plastic applications. This helps us. Without these plastics, we would be so much less efficient in terms of all of the critical inputs. Our environmental impacts would be so much more significant. So plastics in the production of berries aren't going anywhere, and we see them as vital to the production of high yield, high quality fruit. Let's see. So why is Driscolls here? You probably saw there's a few of us here. This is one of our growers from Baja as well. So we have a pretty significant presence here. Why is Driscolls here? Why is a berry marketer here? Well, in the communities in which we work with our growers to produce fruit, we have all kinds of impacts that we have to manage and mitigate, and so some of those are some of those are ones that we can't solve, such as view shed. The plastics look a certain way. Not everybody in the community appreciates that. We have some mitigating factors. There's flooding, there's water erosion, there's flooding and erosion impacts that can be created from the plastic, so we have to mitigate those. In terms of their disposal, there's tipping fees, there's landfills that really don't want to take more of these difficult to recycle plastics. And there's the costs of those landfills and those tipping fees. And then ultimately we have significant environmental impacts in areas where we don't have end-of-life solutions. So even landfilling isn't possible in some of the areas in which we operate. So there are some areas in which recycling is really the only solution. And ultimately, we want to tell a better story than we're telling now, and we think that we are generating a better story than we've had in the past. Mainly with collaboration with the folks up here, so I'll let them get into the details. And then lastly, there is increasing visibility and interest. We don't often see field plastics being front and center in the minds of consumers or customers, but it is in the communities in which we operate, and there is increasing visibility. This is just a handful of some of the articles that we've seen. So with that, I'll introduce Ben Andros, our first speaker. He's the president of Andros Engineering Corporation with over 30 years of experience in farm process mechanization. Ben and his team have developed innovative systems to improve the collection and recyclability of agricultural plastics. His presentation will dive into how machinery selection from installation to removal can optimize plastic recovery, reduce labor, and prepare materials for efficient transport.
All right. Good morning and welcome. Let's do this. All right, good. All right, great. Good morning, welcome. Thank you, James. Been very happy to get to work with James for years now on this project. I can say definitively, without the support of Driscolls and Ryder affiliated companies, we got Barry Mex down here today, this would still be a much larger problem, and certainly we wouldn't have the solutions that we're going to talk about today if it hadn't been for them and the support. Jasmine is here from CMSF as well, getting that down. They'll talk more about how that all works together. And as well as, we were talking about it, it's nothing to do with my presentation, but some of the equipment we're going to talk about today wouldn't exist without this conference. I think it says a lot that it's Friday in San Diego, and there's still lots of butts and seats here. And so there he is, the man. Thank you, Gene. Again, for having us. This is a big part of solving a big problem because it's going to take everybody. And so I'm here to talk to you about really the gap in between the field and a lot of the solutions everyone here provides. So there's some new faces in the crowd, so I'll just introduce Andros as a company. It's a family company that's really focused on the equipment. We're an ag equipment OEM. We build stuff that puts plasticulture products in the field, takes them out of the field, and then increasingly we build a market for those products by preparing a end-of-life solution for plastics through our Ag Services division. We also, because we're an ag equipment OEM, we build lots of other equipment for us and for other brands like robots and stuff like that for the ag tech world. So we're a technology-focused company. We got three main brands. If you go on our website, you see the equipment manufacturer. We'll be talking about the blue stuff, the stuff we sell. That's really supported. Dan Johnson's here with me today. He runs our Ag Services division. It's builds a market for that equipment by helping us recycle. And then we've also got kind of the core of the company is building new technology with our R&D development, which is like a gun for hire, mercenary engineers will come out, solve your mechanization problem. When my dad started the company, that was our focus, and it's still, even though it's the smallest part of the company today, still really informs how we attack problems. So why are we here? Andros's place and really in this value chain, and what I want to highlight today is the importance, if you want recycling to work, to minimize labor and maximize logistics. Yesterday's presentations teed this up for me in fine form because everybody was saying, hey, the issue is freight. The issue is how much it costs to move from point A to point B. And we have found, obviously, this is not going to be a sales pitch today, but the principle that I'll highlight for everyone here today is if we mechanize that field process, you're going to get a cleaner product out of the field, and if you use the right equipment, you're going to be able to pull it out in a format that can skip a bunch of intermediary steps like going to a MRF, dealing with the dirty diaper that gets baled up with your plastic or whatever. You get a homogeneous, as dense as a bale piece of transportable package of plastic to come out of the field. So, yeah, where do we play in this? We've seen a lot of flow charts like this year, so I'll skip right through it. We're really from the application through the logistics, specifically with irrigation plastics, but with helping our partners, whether that's flipping iron or whomever, with getting this to an end-of-life solution. We'll dabble a little bit in some boutique recycling as well for finished products, but that's really where we're at. All right, so because most of the people in here heard, when we presented last year, heard me talk through the mulch stuff, and we're getting a lot of mulch discussion, I think, from our other presenters today. I will talk a little bit about that, but I want to kind of bring everyone an industry update, and ideally with, I'm sure everyone in here is already huge fans of Andros Engineering Equipment, so hey, we'll leave that to the side. Let's just talk about what's the intel that we're getting from the field that you can use to inform your own decision making at your company with what's going on. So first thing we'll talk about is heavy wall drip. James kind of described some of those plasticulture products. This is the drip line that is used in orchards and vineyards, and probably if you live in an arid place, your front yard to irrigate your box bushes, right? It's like big around as your thumb. It's pretty stiff. Can't fold it up, kind of a thing. We'll talk about some impacts of changing how big those rolls are for rolling up ag plastics, all types of it, and then I'll hit a couple things on mulch. All right, so in the western U.S., there's been a big shift. Not a great time for permanent crops, specifically hops, wine grapes in vineyards, and almonds. We're seeing a big shift in the market there with thousands of acres being removed, and that has resulted in a lot of heavy wall drip that needs to come out of the field. There is less of a understanding and historically demand for mechanical retrieval because the service life on a good heavy wall dripper system is 20 years, right? So a lettuce grower who pulls out 3 crops a year may be very used to mechanizing because they have to put in and take out that lay flat drip tape so often. An orchard, not so much. So the issue there is that it's a programmatic problem getting the right equipment to the farmer at the right time. So instead of what we've got at the top, which is there we go, big old nasty pile of unhandleable, super stiff plastic into a roll format like this is important. And it's also being impacted by the fact that there's a growing industry in the U.S. with heavy equipment operators being orchard removal, providing that as a service. So I own a bulldozer. You know, I can go out there and knock all these trees down for you. This person might not understand ag equipment or that how the irrigation system works, or that it's even recyclable. And so there's a chance for all of us in this room, if you have touches there, to kind of inform that. Where on the equipment, it is hard to handle this. So we've played a little bit in there in making a baler that smashes down those rolls into kind of like goes from like Pez dispenser to Snickers bar, if you will, just rams them all together. You know, wow, a baler, right? But we're focused on, you know, that increases the efficiency, decreases the labor involved with handling this stuff. That's where our focus needs to be if we want to get this out of the field more effectively. So where are the opportunities here? Who's got opportunities in the room if you're a service provider, if you're a recycler, or if you're manufacturing heavy wall drip out there? So, you know, Sam, here's your chance to make a big difference. If we could help cut down the amount of silicone that's used in pressure compensated emitters. So if you got a vineyard in hilly terrain, they want to put silicone in the emitter, which is the thing that drips the water on the plant. That makes recycling it a challenge. For recyclers, do you have some sort of technology that's agnostic to the silicone? That's going to be a big deal. If we can get you involved there, there's an opportunity. The Western U.S. is underserved. GTS is here. They handle heavy wall drip. That's good, but there's more than the entire recycling base in the Western U.S. can handle coming out right now. So there's an opportunity if you're looking for a stable feedstock. There is a normal churn of this material that comes out every year. It's definitely higher right now. And then if you are approached by someone or you run a farm where there's heavy wall drip or have touches with them, we need to like, hey, before you have the guy with the bulldozer show up and knock everything down, talk to someone who has, even if it's not an Andros machine, something that winds it up into a donut, a Cheerio. What we don't want is the big hand bundles. You don't want to pay the people to go out there and do it, and it makes a big mess. Cool. Moving on to some scaled retrieval options. You know, you've had the heavy pitch from us for years that, hey, making a big giant roll, this is drip tape, is the most efficient way to get this stuff out of the field. Anytime logistics are important, if you got to store the material, if you want to recycle the material most effectively. Cannot stress that. I think we've landed that plane. But there's some barriers to entry there. One, you need a big old tractor, right? That roll weighs half a ton. So if it's hanging off a 3-point hitch on the back end, you need the big enough tractor to move it. You need equipment to pick it up when you're done. You can't just leave it on there forever, right? It's got to come off. And it's expensive, right? So we kind of answered the call there, and we've got a smaller unit that's coming out, or that's out. They're selling pretty well to help with that smaller, some of those barriers to entry. I want to bring that up just because, thanks James, you're going to get asked this a lot, whether it's our equipment or someone other, vastly inferior winder out there, right? Is that, hey, why can't I use a smaller machine? There are times when that makes sense. Just remember there's knock-on effects for that. You're going to have a roll-off bin. You're going to need a walking floor. You're not going to be able to move it like it is a bale of material. But sometimes smaller machines make sense. So when you're helping someone mechanize their process to feed your recycling operation, then hey, if they can't work in a co-op amongst smaller farms to share the machine, there's an option there. If you can't have other people on the farm because you're doing some sort of proprietary stuff, but you don't make much material, there's still an opportunity there. And there are places where recycling is not feasible, or maybe the product it's not as important that you get it recycled, but you got to save on labor. So that is an option as well. So just quickly on that, I wanted, after pushing that so hard last year, to let everyone take a breath. I get it. There is a time when the smaller format makes sense, but just be aware that there are some challenges that you'll be developing downstream. Opportunities here, we get a lot of demand for a smaller unit from like community support organizations, MRFs, who are looking to help the market farmer clean that kind of stuff up as well. All right, last thing, just a quick mulch. This is a much more cheerful this year than it was last year. We've had a year behind our belt talking about the technology that Theron will bring up here in a minute, of cutting these thousands of acres now of these big mega rolls of mulch with a guillotine and trommeling them as a pre-processing step. That has been a winner. Theron, we'll talk about that in a minute. Just remember it needs to be in a big roll format. And then also, the industry's answered the call there on the mulch retrievability side. We've been working with Viaflex on, hey, how can we look to pull some of this mulch in more effectively? And we're finding that the proper application of some technology, the current state of the art in terms of retrieval technology responds extremely well. So very promising going forward. So we're having some good success with mechanical retrieval, good success with mobile pre-processing. I'll be available to talk about those during the Q&A since we're running out of time here. Who's got opportunities here? Mulch manufacturers, lots of room in this for everybody to play as well. Farms have an opportunity as well. Just as a note from the field, what we're seeing is that labor pressure on mechanizing the mulch retrieval has increased. It was already increasing, and it's hockey sticking, right? There are only so many things, particularly in berries, that can be mechanized. And one of the last things that isn't fully mechanized is retrieving the mulch. After that, it is the great white whale. It is robotic harvesting. So we're going to need some 100-pound heads to figure that one out. Very challenging. Mulch removal is one of the last low-hanging figurative fruits here. And so we're on that. There's a big demand from industry from that. And then again, opportunity for recyclers here. Zero cost, highly concentrated feedstock for especially mulch film used on berries, since they're all grown within small areas and geographically central, which, as we saw yesterday, is super important if you're trying to source this feedstock. All right. How did I do on time? Good? All right. Thank you.
So I'll start off with a question for Ben, and then we'll open it up to the audience for more. So Ben, you covered some advances that are happening in California, and Theron's going to speak more to that in detail in his next presentation. But can you tell us what's happening beyond California? How do these solutions apply to other regions outside California?
Sure. Yeah, absolutely. Almost as if I knew that question was coming. We're seeing the Southeast is by no means. California would love to say, oh, we're the leaders in everything, right, technology-based, but a lot of that is really driven by the regulatory framework, not necessarily what people want to do. There's less of that in the Southeast, so traditionally there's been less demand for recycling, but I think that's changing, and I think we'll hear about that. I know Ishmael's based down there. So in the Southeast, we've got mega minders down there, and we're also seeing a lot of international demand for this equipment down in Baja, Mexico, where kind of to James' point earlier, there's not a great option to landfill this material, where growers down there are using our equipment. There's been robust interest in getting it at least into a format that isn't blowing away, right? Like if you just pull it out with your hands and put it out in the desert, now we have a big problem, not to mention a bunch of rattlesnakes. So if we can just get it into a nice unitary format and then stack it on the ground, it seems very simple, but the impact is outsized because now it's in a nice tight roll. It's not blowing away into the wilderness. We can get it on a truck, maybe get it to a recycler, or even more effectively to a landfill with fewer energy inputs, if that's the only option we've got right now. But we're kind of triaging the problem in some of those markets where there isn't a really good solution. We're doing our best not to make it any worse as we work on some of those follow-on recycling options. Additionally, if you're working internationally, I'll say now is a great time to buy equipment made in the US based on the exchange rates. So we're sending containers loads of equipment to South America, which has been honestly pretty fantastic for us. Happy about that. And we think it's based on the strength, the relative weakness of the US dollar, making buying stuff manufactured in America more appealing. So thanks, James. Great question.
Anybody have any questions they'd like to ask Ben? He's a good sport. You can ask him some tough ones.
Just curious. Oh, sorry. Thank you. Simple question for a simple brain. I can't operate a microphone. It's on.
We can hear you.
Okay, great. Just curious on your bale sizes, the big square ones that you had a slide on, and then also on your rolls. I'm just curious because I've seen them in roll-offs and flatbeds, but what is the weight on the giant squares, and then on the spools? I mean, how much of a difference does that make maximizing freight, I guess?
Sure. Yeah, great question. So the bales are sized to stack 2 wide and 4 high, or 2 wide, 2 high, make a wall of 4 and a 40-foot high cube. So you have a little bit more room inside of a dry van. And you make axle weight, no problem, even with a high rebound material like drip tube. So you'll max out the container or trailer. A container will maybe depending on, interestingly enough, if you're trying to smash down drip tube, it matters how hot out it is. It's a nice and warm day, that stuff packs down pretty tight. If it's pretty cold, it can be pretty challenging. But nice hot day, no problem making axle weights on all that. The rolls are so dense, you should not put them in a baler because they're basically a rock. If the operator's running the machine properly, it's as dense or denser than a bale because of some proprietary stuff we do inside with and tuning we do on the head that pulls the material in. It tightens that plastic, and if it's like drip tape, it's basically a giant spring, so it smashes down on itself as it winds. And we've tried putting them in a baler before and blew it apart. So it's as dense or denser than a bale. It goes right on the truck like that.
Thank you. Sam in the front row.
I can repeat his question. Thanks, Rory.
Just for kind of the rest of the folks here, could you just kind of elaborate a little bit more on the need to kind of separate the materials when you're collecting? Because I know you have beds where the tape could be on top, the tape could be a couple inches under, you could have a mulch row, you could not have a mulch row, and just kind of the needs to differentiate those streams.
fantastic point. Yeah, it is important. If you want to sell your ag plastics, we need to maximize the good things and minimize the bad things. Some of the bad things we can't get away from. Berries stuck to the plastic, dirt, water. I mean, it's an irrigation plastic, so there's going to be some water, even though we do our best to get rid of as much as possible. One of the great things about ag plastics, as recycle it, is that it's all one thing, right? And if you retrieve it in the field, the chances of commingling it with other plastics are much lower. So if you gather it into a bin and take it to a MRF, there's that interstitial time when it's moving. They're processing one material and moving to the next. So one bale is going to have a bunch of milk jugs in it, as well as your tape, and very fussy recyclers, which I'm sure there's none in this room, will complain about that, right? So we don't want to mix the materials. One of the problems with mulch is one honestly effective technique for making it easier to mechanically retrieve is to pull the tape and the mulch up at the same time. Because as James mentioned, the tape is underneath the mulch, right? So and it's much stronger than the mulch. It's thicker, it's 2-ply, it's basically a plastic rope. So if you grab that and the mulch with a machine like one of the ones we built at the same time and pull up at the same time, you can often free it from the bed more easily. So farmers have gotten used to do that. But now we have usually generally the same polymer, but different material properties, feeds differently, doesn't sell as well as a feedstock. So really important that you mix that, and then you minimize overall contamination. One other thing to look out for, and you can, if you're interfacing with a farm, I'm not the one out there at 2 in the morning fixing an irrigation blowout. So if a PVC coupler is all you've got to fix that heavy wall drip line in your orchard, that's what you're going to use. No problem. But as it's coming in, you can save a lot of time by just snapping that off the roll and throwing that in the bin and then retrieving the rest of it. Because that can also cause, obviously, big problems for recyclers if we're bringing in PVC fittings. And that's a problem for irrigation. Good question.
Hey, Ben. Is this on? Oh, yeah, here we go. Good work, and good work for all the guys you guys doing out there. So I'm Bill Turchik, the California Strawberry Commission. Remember last year, you guys, one of the challenges you had was the thickness of the film. And I think maybe at that point in time, you sort of challenged folks like to make thicker films. Has the industry responded in creating thicker films, making it easier to pull off?
Yeah, definitely. Viaflex guys will chat a little bit about some opportunities, I think, and that. There's definitely, we've been working with that as a tactic. Seems to work as we kind of expected. There's going to be follow-on agronomics that we need to make sure. Every row of strawberries is worth a lot of money. So anytime you tap anything that has a follow-on effect for the product, and I always like to point out that the farmers we're all selling gold pans to the miners, right? The farmers are the ones out there actually doing the work. So I'm very sensitive to their hesitancy to change anything that's going on the farm, because if it affects the crop, that's going to be a big deal for them. So yeah, very promising early results there. I don't want to steal anyone's thunder on that regard, but very promising. And I think the agronomics, meaning to say how it affects the fruit, will either be positive or negligible. So should see good results from that. I'm hoping next year that we'll be able to, and then the following years, keep building on that momentum. Quick one, Ted, then we got to cut it off.
Yes, quick one. On the heavy wall drip tape, how much of the silicone emitters are on there? Do you have an idea of how often they are? Or?
Good question. It depends. Lame answer. Good question, lame answer. It depends on how far apart the plant is, right? So if it's in trees that are spaced 12 feet apart, obviously they're going to be much more distant. If you're on a crop that needs one every pot or something like that, they're going to be much closer together. So ask early and often if you're buying this feedstock for pictures. And hey, the question you want to ask if you're a recycler is it pressure compensated? And they should be able to say, or is there silicone in the emitters? And if the person winding it up doesn't know, then reach out to just hey, who is your irrigation dealer? And they'll tell them exactly the brand and everything that is running. Good question. Thank you.
Hey, thank you, Ben. And if anybody else has any questions for Ben, we'll have a general Q&A session at the end, so you can ask it there. So our next speaker is Theron Smith, co-owner and founder of Flipping Iron Incorporated, a California-based industrial recycling company specializing in metal recovery and agricultural plastic recycling. With 25 years of hands-on experience in the recycling industry, Theron has been a pioneer in advancing ag plastic processing on the West Coast. Today, he'll share insights into the latest trends and innovations in ag film recycling, from expanding recovered material types to improving processing efficiency and developing new market outlets. So please join me in welcoming Theron.
Thank you, James. Excited to be up here again this year. Just wanted to really take a moment, and when I was formulating this presentation, I was still working on it this morning, and but shout out to the room. You know, let's give a shout out to the room. I think we kind of maybe rename this instead of right now it's the APRC, maybe call it the APRC GSA, getting stuff accomplished. And that's really what I think we get here in the room. I think you guys all deserve a round of applause, and yes, that is getting stuff accomplished. My wife's watching this. She'd be mad if I said anything else on at this point. But no, we have, when we look at the room, you know, we have people that are in fast recycling, we have brokers, we have ones that are actually processing, we have ones from other industries that are helping us out to maybe move forward in this area, we have manufacturers, and we don't want to discount anybody. We have people that are helping in regulatory areas, students, and really it's going to take all of us to accomplish this. I'm a small cog in the whole stream. We have a very specific operation with flipping iron. We're never going to compete with Ben in manufacturing equipment. I'm not that smart, and I don't have that much patience. We're never going to manufacture film. Flipping iron will never be the next film manufacturer. We're never going to manufacture drip tape. We have a very specific location in this market. And really, that's what we're going to talk about, but we're also going to ask for help, which I think a lot of people have already done. A lot of people have already highlighted how that this needs more help, this needs more awareness to be able to solve the problem. Kristen made a great point yesterday. At the end of the day, ag film is only dirt and water and rocks that's preventing us from getting it recycled. So it's not an insurmountable problem, but it's been a problem we face for a long time. So flipping iron, I guess I gotta control this, eh? Flipping iron, we have cut our teeth in recycling as the ones that recognize the problem, then find the solution, and then find the equipment in between that's gonna get it there. The equipment and the partners. So we've done this in many areas. You saw an example of this machine. Ben had it on his slide. I wish I had that slide. That would have been a nice slide for me to have on here. But you know, we've done it. This is an example. Well, some of these are the materials that we've tackled: tires, trash cans, mulch film, fumigation film, hoop house, drip tape. All of these things have their unique challenges. Maybe you say, well, trash cans, that's easy to recycle. Well, when you get a dry van full of 10,000 pounds of trash cans and that's all you can get in there, it's a lot of trucking. You know, logistics once again comes into play. We should have a hashtag that said Ted said it, right? Because I think that's come up like 4 or 5 times that Ted said it. You know, and these other ones, it's logistics and dirt. Fumigation has its own problems with being the type of plastic, the glue strip, and also what's under that. We had to help farmers to realize that, look, the recyclers realize that the fumigant is gone. You know, the half-life of fumigation is gone by the time you're gonna get that plastic. But it's making sure we understand that process and moving forward. So here's some of the examples of solutions we've found. PVC, it is recyclable, believe it or not. You just gotta get it in a form that people wanna recycle it. Tires, they are recyclable too. You just have to get in a form people want to recycle it, and you also have to realize that there's not a lot of value in this recycling. So who's going to compensate that? Moving forward, this is from Kristen's industry, corrugated storm drain pipe, highly recyclable, but she brought it up yesterday. It's shipping air. So you can't ship 5,000 pounds to a recycler and expect them to downsize a 5-foot wide pipe and say, but I also want you to pay me for that material. It's not going to happen. So much like Kristen does, we go on site and we process it on site. This is more example of that similar process there. Just when we see the problem with flipping iron, not the problem with flipping iron, when flipping iron sees the problem, then we try to go find the solution, and then what's the equipment in between. And that's what we really are trying to bring to this. Here's an example of aluminum pipe. We think, well, aluminum's got a lot of value to it, and it does. It absolutely does. However, a load of aluminum pipe in a large truck is only going to weigh about 6,000 pounds. So if you're shipping aluminum to anywhere and you have 6,000 pounds in it, your price is going to be extremely large. So we figure out technology, equipment that turns it into a bale on the farmer's site. This is an example of fumigation and mulch film, all just showing that as a company, our goal is to, once the problem is identified, and then we find the solution to go get the equipment. I think Ben made a comment at a previous show. We're not looking to go get equipment in search of a problem. We're trying to find the problem first, then the solution, and then the equipment in between. So this is just some of the examples. We recognize the Andros Mega Binder there, a huge help in recovering materials. Just that step alone has taken mulch film from a yield of about 30% on average from the farmer's field to something closer to 45%, 50%, just farmers implementing that machine. We saw the problem, James brought us the problem, we found a solution. Hey, how can we get this to traditional mechanical recyclers for export, which we already worked with? That was the solution. That machine alone right there got us really, really close. And so we bought a fleet of 22 of those. And we're still growing that fleet. This is a large shredder. If you can recognize like what that little emblem is, Teenage Mutant Ninja Turtle shredder, thing right there. But we bought that. That's what we use to send out through the country to help with mobile shredding of large pipe. This is our first mobile baler. This is the one we just finished building, and Ben actually is building us another one. So we will have by the end of the year 4 mobile balers. 2 of them are probably going to go out of commission, but we're just trying to improve. And then this is what we use to help with a lot of metal. This is a large, weighs 100,000 pounds. But we can take it to people's site, bale up, log up a lot of metal. So just kind of some of the success stories of what we've done. This is supposed to be a video. I kind of procrastinated a little bit, and so you're not going to get to see the full video. If you want to see it afterwards, I think there's a QR code. You're welcome to see it. But this just shows the trauma line that we talked about last year. Last year we saw a small prototype of it, and really it's the next phase in what cleans up ag plastics. No water. It takes the mulch film, chops it up, and turns it into, now it gets that mulch film to maybe 60% recovery, which is really kind of the magic number in traditional export mulch or ag film recycling. People want 60% yield. Drip tape minimum is like 60% yield. They usually want 70% there. Hoop house, almond film, things like that. They want that 60% yield, and that's what this really gets us to. Low cost, it's agile. We don't quite say it's portable because it's not on a trailer itself, but we can load it up onto a trailer. We can move our whole plant within 3 trailer loads in 1 day, and we can be anywhere on the Central Coast for recycling mulch film specifically, or fumigation film specifically from the strawberry industry. So what have we done? Flipping Iron has worked with Andros in this specific space to be able to improve our equipment. Our trauma line is twice as long, or more than twice as long as what it was before, so the plastic stays in there longer, knocks off more and more material. When Ben and I first worked on this, we thought that 4th bay and the trauma line, because there's 4 bays that collects the material, we thought, maybe we'll dump it once a month, something like that. We were actually finding out that it actually is still knocking off material all the way to that 4th bay. So it's only going to get it cleaner. It stays in there longer. Even the conveyors we have are very specific to what we do, and the way we don't shred the material. We try to make that very clear that we chop the material. I was holding up a napkin earlier, a cloth napkin, and the ribbons are about the size of that, because then it doesn't fall through the holes of the conveyor or the trommel. I wish I had the picture up. I'm sorry. Thought we would have a video, but if you want to see it, please jump on our website, talk to Ben, wherever you want to go. You can definitely see the advantages. And then also better training. Adolfo here, he's with my team. A lot of you have met him. He will testify to the fact that the farmers are getting better and better at rolling. When we first started this 3 years ago, we were dealing with some sketchy rolls. And now, even for the toughest material, which is what we consider skunk film, if you're a farmer, you know what that is probably. it's getting better. And we, testimony to like, hey, proper training really helps this industry a lot. Ben was talking about, you have a mega binder roll that weighs half a ton. Well, I've seen of drip tape, I've seen mega binder rolls that are completely rolled, big rolls, and they weigh 300 pounds. And it's how you roll and training the farmer to make sure that he's doing it the correct way. And then a huge help is larger industry adoption rate. I can't say enough about the fact that this industry, the strawberry industry, whether it's the nurseries, the growers, their support in this industry has really helped solve a large portion of mulch film recycling in California. We're going to get in a little bit more about other industries and the complications we have there, but the large adoption rate, we're at over 10,000 acres last year, and we look to be over 10,000 acres this year. So the question is, what comes after strawberry success? So I have a question for the audience. You just yell it out. I don't need specific ones. Who here can name a watermelon brand? All right. You don't count. You're in you sell to watermelon guys, all right? All right. Who can name a tomato brand? Once again, he doesn't count. All right, we got one here. All right, there you go. Who can name 2 strawberry brands? Right? Everybody, we know brand name in strawberry is huge. Driscolls, Giant, if I'm forgetting I know right now I'm blanking on all the rest, but I at least got Nature Ripe. There you go. Brand name is huge. You go to the store, what do you see? Big boxes that say Driscolls, Nature Ripe, Gym Pack, whatever the case is. The brand is big. The crops are valuable. So there's a little bit of help when it comes to mulch film recycling because of that. Watermelon grower maybe doesn't have as valuable of a crop. Maybe doesn't have that, brand name behind him. So he sends out his watermelons and he never really has to hear about it again. Not saying that they don't care, not saying that they're not responsible. The reality is the brand name helped this industry, and we can't discount that. So how do we overcome that? Well, we're not here going to be able to say let's educate everybody on the brand names of watermelons. We have to look at more of opportunities of how we can just all take responsibility and to all take the initiative to try to figure it out. Landfill prices, one thing about strawberries, I've heard it said multiple times before, they grow where people want to live. So if you don't handle them responsibly, then people will say, hey, you know what, let's get rid of this crop and let's put houses there. They grow in coastal areas, especially on the West Coast, where people want to live. Very expensive houses, very expensive living in that area. And so because of that, they have a huge public perception. And so there's a lot that goes into why strawberries have been successful. We want to see how we can make the watermelons, the tomatoes, the peppers, the gourds, all of those things. How can we be successful there? They're going to have their own unique challenges. They're going to have their own unique circumstances. But once again, flipping iron's idea, recognize the problem, find the solution, get the equipment that will accomplish that. And we don't know if we definitely don't have the solution yet. We never recognize the problem, but we need help on finding that solution so we can get the equipment that will allow us to go from there. So I'm going to actually stop here. I think James has got some, questions, and then we're going to, and I might, we might finish the slides or we may not. We'll see. There's no rules anymore, right? I mean, I'm up here talking. There's no rules.
Yeah, really good progress here. I've got a couple, it's really a 2-part question. What are, just in terms of metrics, how many acres of material have you recycled, or have you collected and pre-processed and shipped out for recycling in the last couple of years? That's one question. And then, what are you seeing in terms of your initial recovery rate when you first started this process 2-3 years ago versus what you're seeing now with some of the advances, the new equipment that you have in place? So.
Yeah, no, I appreciate that. Kind of talked a lot about some of that stuff already. Last year, if you remember, the first trial that we did with the Andros, and really, like I said, Ben did this. I just was there to help facilitate it, but Ben and his team did it. We did 30 acres, okay? And that was, I don't know if it was highly successful, but it was successful. And it was successful enough to say, hey, let's try 200 acres. And now we're to the point where, like I said earlier, we're doing over 10,000 acres. It's hard to tell because, especially with fumigation, sometimes they inline fume, sometimes they flat fume, and that'll kind of dictate how many acres we get. And also sometimes timing. A farmer, if he's got to turn his field and we're not there quite as fast as he wants us to, which Adolfo really tries to do so, he might just rip out all that flat fume and just continue on. But there's a possibility this year, depending on what comes off, especially in the Watsonville. We're about halfway through the year. We see Santa Maria coming up, and then Watsonville to follow suit. By January, we could possibly up to be right around 14,000 acres this year. So it might be a little bit pie in the sky. Adolfo is probably like, I don't know what you're talking about there, but if a lot of the material comes off and we were able to get our hands on it, that being the case, I think the biggest success in this whole operation is the Mega Binder and what it does for fumigation and for mulch. But the next biggest is obviously the processing line. The processing line has been huge. A little early, James, unfortunately, to say exactly what the increased yield is because we just shipped maybe 2 months ago the first processed material off of the processing line, and so it's just getting there. Southeast Asia doesn't always like to tell us how clean the material is, so we try to get that information. I mean, they'll tell us, but we always kind of question it. But like I said, we know we've got it up to about 50 to 55%, or 45 to 55% consistently with the old version. And if you saw the new version versus the old version and how long it stays in there and how much material comes off at those next 2 bays, the first version only had 2 bays, this has 4 bays, so the last 2 bays, we've seen no doubt that there's at least a 5% increase, which we know that that's not a lot, but when you're shipping dirt, if you're shipping 5% less dirt than you were before, then it's a good result.
All right, thanks, Darren. Let's open it up to some questions from the audience. A couple hands raised here. There we go.
Tom, PDO Advanced Recycling. So at the end of the guillotine trommel, what's the form factor? Do you have to rebale that, or how are you shipping that out?
Yeah, so I mean, that's appreciate that question. So, we are right now baling it, but that's, like we said, for more of an export opportunity. We definitely have seen that that's really what they want. I think as a domestic opportunity, there's a possibility that equipment can go into place after the trommel that would allow for more of an export, maybe even more cleanliness, but right now, yes, it is a baler.
Hi, Trevor from SPR. Down gauging in mulch films is a solid win in terms of reducing the amount of polyethylene per acre effectively. And we understand now that retrieval is not much of an issue if it's done properly.
Right.
My question is to someone like yourself who has to collect and recycle, is it a hindrance? Because the ratio of dirt per surface area or per pound of plastic goes up significantly as you down gauge. Do you find that to be a challenge?
I really feel like he's setting me up here. There's like manufacturers everywhere. What I say here is gonna, everyone loves the idea of down gauging. I was talking with Claudine this morning, and we brought up the point that you take a piece of plastic. If you take, let's say, a 6 mil versus a 1 mil, and you rub that piece of plastic along the ground, each one of those pieces of plastic is going to pick up the same amount of dirt. It doesn't matter if it's a 6 mil or a 1 mil. The difference is how much plastic to dirt ratio is there. Down gauging is a great option if you're going to the landfill. From my side of things, this is a very specific side of things collection. If you're going to landfill, it's a great option. For recycling, just like black is a horrible option, so is down gauging, because the ratio to dirt to plastic is so much worse. Now, there's arguments to be made against that, but the reality is the dirt to plastic, the thinner we go, the more dirt there is to that plastic. You can argue, well, you're putting more plastic on the ground. Those are valid points. I'm talking about from a recycler standpoint. What we want is thicker plastic. If somebody said, hey, all of a sudden I got a 2 mil, or well, actually we got a good example of it. He talked about high tunnel film. We can talk about low tunnel film, which is clear, and it sits about 6 inches off the ground, and that recycles barely better than fumigation. It's clear, but it's thin. And it doesn't have a glue strip, barely better than fumigation. High tunnel films, 6 mil, sits out there for years on end, and yet we can still get in the above a nickel for that material on export. So it just, thin hurts us, always will. So. No, no, no. Yeah, exactly. The other one's
I think it's. Can you hear me?
Yeah.
I just want to. If you can't pull it out of the ground with your hands, you can't pull it out with a machine, and that's the limit in terms of leaving material in the field. Down gauging, it's conceivable that a machine can be made that pulls out, 0.75 or 1.25 mil plastic, but generally you end up leaving big chunks of plastic in the field. So that's the equipment limitation. I'll just leave it on that. That like if you can grab it and pull it and break it, then we can't replicate a human hand for picking strawberries yet. We're not going to be able to replicate it for pulling mulch out of the ground as well. And if it breaks when you pull it out with your hand, it's going to break when you pull it out with a machine as well. So that's the other upside to upgauging.
Yeah. Hey, I know he's going to wrap me up here, so I just wanted to say one thing about we said it last year, flipping irons in a precarious situation because if export dries up tomorrow, we're out of a business. Ben's still recycling, James still growing strawberries. We're out of a business as far as mulch film recycling goes. So, these are options that we see that a lot of them have been talked about today. Turning mulch into something like a pellet, something like that for domestic, it's doable. We've heard about it. We've heard about it probably 2-3 different times in this session. But who's going to take it? Who's going to consume it? Asphalt, great. One of the things that we've explored, we've actually had some success, is exporting to Southeast Asia and utilizing them the way China does. Let's not convince ourselves that China doesn't take in recyclable material. They absolutely do. They send it to, instead of us sending it directly there, they send it to Southeast Asia. It gets processed into a pellet, then it goes into China. We talked about this yesterday with some people. It's cheaper to go from LA to Malaysia than it is for me to ship from Oxnard to LA. And if you don't know that distance, that's about 110 miles. And yet it's cheaper to go from LA to Malaysia. So is there an opportunity for manufacturers to utilize Southeast Asia the way China does? We're not here to say what's a good or a bad idea. These are just ideas. Clean burning fuel, composite wood, advanced recycling, and then the big question, what's your idea? Because we're here, if you can help us find the solution, we'll buy the equipment. And that's flipping iron, that's what we really hang our hats on. So thank you very much.
Okay, thank you, Theron. Our final speaker today is Ishmael Rodriguez, CEO of Second Recycling. Ishmael brings 19 years of experience as a mechanical engineer and business leader in the recycling industry. Strong focus on sustainability and process optimization. Today, so we've gone through material selection for retrievability. We've talked about equipment and techniques and technology for retrieval. We've talked about logistics and collection at the field. And we've talked about regional pre-processing as well. So today we're going to wrap it up with Ishmael, who's going to take us behind the scenes of an operational agricultural mulch film recycling facility in Florida. He's going to share practical insights on collection, cleaning, processing, and strategies for producing market-ready recycled materials that support circular economy goals. So please join me in welcoming Ishmael.
You hear me? Okay, perfect. So thank you for having me here today. Gene, thank you for having me here to speak to you today about mulch film recycling. We've heard a lot these 2 days about the equipment that we're actually using to actually perform this task of size reducing, cleaning, and actually transforming it to a final product. And a lot of the things that you've mentioned is the challenges that I actually have to work with every single day. My panelist, Ben, with the roles that he has, I think he was spot on with the guillotine and the trommel processing, because it's a great form to pull the material out the ground. But sometimes when you don't have the proper equipment on your facility, you run into challenges. And that happened early on stages, like a decade ago when we were up and coming as a new company. We weren't prepared completely to receive all these types of material, and we had a hard time. But after we integrated guillotine into our system, it went smoothly, and it was an easier material to handle than actually the loose material that we actually received. And that challenge was overcome by just adding that extra piece of equipment to our process. So as a processor, we pretty much just receive the material. We do not get the hard hit from the freight. We actually receive our material in the facility for free. So that's something that the growers actually like, because they don't have to pay the cost for landfilling the material. So some of the bigger companies actually take advantage of this near states, like from Alabama, South Carolina, Georgia. They will actually bale up the material and end up sending it to us in flatbeds, and we receive it in our facility. So we have 2 seasons during the year that we actually receive between 250 to 350 loads, those two times of the year. And that's pretty much to handle the yearly production and actually have a little bit left over to continue. So basically, when we receive the material, we stockpile it in our yard. We have 15 acres where we actually just keep our material there. We try to leave it there to rest for at least 6 to 8 months, just because we try to get all the vegetation to actually die out before we go into it, and try to eliminate the vegetation that's still present and still live, because most of these growers, when they're pulling out the material out in Florida, they have a lot of like tomatoes that are still growing, and watermelons, eggplants. And if you actually add to that, to the system as is, we use a wet system to clean our material. And it gets a little bit funky, the smell inside the facility, so we try to keep it as minimum as possible of fresh material coming to the facility as we process it. Now, as I go through, many of my co-speakers yesterday spoke about the process that we actually use to actually size reduce and clean this material. But in Florida, I would like to add one more variable that actually happens to us. It's about the sand. We do have the dirt and everything, but we actually have a very sandy soil in Florida, which is a very abrasive material, which is completely bad for your process because it dulls your blades almost immediately. So you have to keep up with the maintenance of the machine so you can actually have a more efficient process and keep up with the volumes that you're actually trying to accomplish during your production day. In our system, I see a lot of faces here that actually visit us before in our facility. And we have almost 2 acres of settling ponds, because we actually use almost 3,000 gallons per minute of recirculating water just to clean the material, to the point that we get it to the extrusion system almost at 99% clean from all the debris that it actually comes into. So I'm just going to walk you through some of the equipment that we use and what are the best practices that we're actually using to actually accomplish the cleanness of this material so we can put it into our final product. We are fully recycling line. We go from size reduction, cleaning, and to pelletizing our end products, that our end product will end up to some advanced recyclers, and that's what we pretty much do in our facility. But I'll walk you through all the things that we have. So the first step that we do, we have a dual shaft shredder. Also, we do have a guillotine when we're working specifically with the rolls. What we've done, we separated that operation before the dual shaft. And when we're just processing rolls, we pull up our guillotine, we turn it on, and then we start cutting it down, because we've noticed it's much better and much efficient to cut it down through guillotines, because you can control the amount of materials of that roll, and there's a specific way to handle those types of rolls, a little bit more efficient than just throwing it into a dual shaft shredder, because some of the time, if the conditions are perfect, they will wedge into the both rotors, and it will just continue to go back and forth, and it actually causes a lot of grinding to that machine. But by passing it through a guillotine, it's a little bit easier to manage those types of rolls, and you can actually mix it in with a loose material, and everything goes through very well through that dual shaft shredder. We have actually gone with testing 3 types of dual shaft shredder, and we found that one works better than others if they're completely programmed correctly, and you can do a lot of tonnage through these machines. It's just how much you need that it can actually keep up with the wash line that you have. From there on, just like the processes here in California, we go to a trommel, but our trommel is a wet trommel. And there we're knocking off all of the coarse material that we actually encounter in our materials. So we got a lot of rocks, we got a lot of vegetation, barks of trees, everything that can actually present. We get dead animals and a consistent base coming through here, so that's something that we actually have to remove as well. We did some metal particles coming in through. We get cans and bottles sometimes because in the collection process, they treat this material as garbage. So they try to mix everything in, and sometimes in the farms, and we don't have that discipline still in our farms. And they actually throw some garbage in there that we still have to mitigate. And we try to pull off by hand when we see it, but if not, the system is capable to pulling off all those types of materials that we don't want in the process. From there, we go to our second stage, size reduction. We go to a single shaft, and this is a dry system, but the material is so soaked and wet, it continues to clean itself, and it continues to drip all the sand that's present there. A good thing about this system, we have an oversized system, which helps us a lot because it keeps the material looser than smaller units. And that's what we found with time, that we had a smaller unit before, and it actually compacted more of the material at this stage. And then we had to have a lot more agitation to clean it. But having a bigger unit helps us a lot because it keeps the flake a little bit bigger, and it's easier to actually process downstream. Now, from there, we have a series of 3 wash tanks in series where we continue to agitate and force the material under the water to completely get it clean. It's a very efficient, low-cost process that we've actually discovered during the years. We've had a very complex line, and we have a very simple line. And the simplicity of this line, it's been something that we've seen that is actually very favorable for us because it reduces costs, and it actually cleans the material a little bit better than the more complex lines that you see around the U.S. From there on, we go to a mechanical drying process, which is just big centrifugal dryers. And we have 2 centrifugal dryers in series where it actually starts removing all the water, and it removes any type of foreign material that's still present inside the material stream that we've already chopped up. And it does a very good job of separating the water, and it comes out with a moisture content of 11% coming out of this system. And from there, we move into 2 thermal dryers, which are in series, and we just blast hot air like crazy there. The gas prices in Florida are pretty cheap, so we try to get that material as hot as possible so we don't have to transfer much humidity into our extrusion process. The material coming out of that comes out to be 0.4% moisture level, so it's very dry as soon as it passes through these coils. And it's amazing because whenever you lose a dryer, you'll get moisture, and then the extrusion process will actually start getting some defects, and you lose control of your extrusion process because of the moisture. Even though the extruder that we have is vented and everything, it still doesn't like the moisture. So we have to be as careful as possible to send all the material that we're sending to the extruder as dry as possible. And pretty much we have a 37-to-1 extruder that's actually capable of handling 2 metric tons. We don't go up there in our production. We keep it a little bit lower, half of the production. We keep it around 2,200 pounds per hour in our production rate. And it does a pretty good job. There's some things I would love to improve about our extrusion line. I think that any recycler should move in. They're trying to actually invest in equipment. They should go into a cascading line. It will avoid a lot of moisture contamination and other gases that are present. But in ag film, it's a very good material to process because you're not worried about the labels or the ink that's actually present in other types of material that you're recycling. So that gives you the ability to avoid some of the equipment that typical recyclers have. Like we can avoid a lot of friction washers, turbo washers that are actually in the other recycling systems because we're not worried about the glue that's actually present in the material as well. Pretty much in the economics of the lines, I mentioned that we've been able to streamline a lot our system during this past decade, and having a very complex line, a full line with friction washers, a lot of pumps, just trying to clean the machines, you'll see that it has a power consumption of around 1.6 megawatts per day of consumption per hour. And by streamlining the line, you can actually reduce over 50% of the energy consumption by using a more streamlined line than the conventional wash lines that you find out there. It actually helps out also on the water consumption because it has less moving parts. It requires less waters in different areas as well. So between the ability to process in a very complex line versus a streamline, there's always a benefit of doing things simpler and getting the job done correctly. Yep, so this is pretty much some of the stuff that we're actually working at Second Recycling right now as well. We're doing some rigid plastic and we're introducing rigid plastic as well to our stream just because our customer wants a little bit more rigid plastic present on the pellet side, and we're able to mix those crates that are coming from the ag film as well, and that's some of the things that we're doing, some of the plastic crates that comes from them, and they're loving it at the moment. We're going to be doing other stuff interesting, and I mentioned about nano materials the other day. We're also going to be master batching ag film pellets with graphene, so we can actually start producing other thermoplastics that are more valuable, and we can actually increase the value of the pellet at the end by introducing these nanomaterials. And this is pretty much advanced recycling that we're actually focusing on as well. We probably want to be next year looking into trying to bring a module up online, and we're working with a group that's called GraphWorks as well. And we're trying to make this happen as well for second quarter next year to bring an advanced recycling facility as well. So pretty much this is our site. You can see it on the far left. This is operating. This is our retention pond for the water where we recycle. And this is all our feedstock that is here. This is an old photo. It's gone down, it goes up. It all depends on the season. But we've been going through a lot of material these past year and a half, and that's what we're trying to do. We keep the momentum and the material flowing so we can do it. So I mentioned that we leave it around 8 months just because we don't want to deal with the rotten water, and we try to keep it as simple as possible in our water treatment system as well. So the water, we just gotta let it settle, and then we clean the sludge at the end, and we dispose it as industrial sludge at the end. And the residual sand that comes out, we have to send it out to landfill cover only because the microplastics are still present in it, and it's the only place I can actually take it right now. Years back, I can send it out anywhere, but right now, I'm a little bit more restricted where I can put that byproduct of the sand. This is in collaboration with Swix. Swix actually had a grant, and we did a project for a year in our facility. That machine was provided by eFactor 3, and we did some size reducing with this mobile shredder. We tested mobile trommels and shakers, which we had a very good success doing it completely there, and that's one of the tests with a mobile trommel as well with a shredder. And that's pretty much the circuit of water that we have in our facility. And you can see on the far, back here we have our trommels, which are wet trommels, and that's how we work with it. Our material to knock out all the sand and everything. So it's an interesting small process that we have, and it does a lot of material during the year, and that's some of the sands we recover. Just to give you an idea, on a day of operations, we can remove around 30 yards of sand on a daily basis. This is our final product pretty much that we're making, and that's what we're sending out to an advanced recycler right now as a finished product. So that's pretty much my presentation. And that's a little bit of what we do over there. So questions? Thank you.
I'll just start off with a quick one. What are the current those pellets that you're processing? That you're producing? What is the typical end use of that material versus what's maybe your sense of the ideal end use?
Okay, so we currently sending it out to ExxonMobil, and they're using it for advanced recycling in their facilities out there. But mostly before advanced recycling was actually having this big boom these late years, it was actually more going into injection molding material and going into partially film production again. The problem with ag film for film is that you still get that cross links and you get those gels still present, so they can use it, but they can use it at a small percentage in their blends. But if they use it for injection molding products, it's a very great product for them. It's almost all black, and you can be able to add color to it and another additive to actually supply it to any customer on the form they want.
Thank you. I think I saw a couple other questions coming up from Sam. Can we pause that video?
You can just go to the last slide or something.
Sorry.
Awesome. No worries. I guess two questions. One, I'm kind of curious about the 8-month heuristic that you're using. I would imagine that depends on kind of the surface that you're storing it on. I know that there's some kind of thoughts on storing the ag plastics on like pavement so you can let like the dirt run off and not pick up any new contaminants. With kind of the vegetation mixed within the plastic, I'm kind of curious beyond like solar degradation, you likely need soil microbes to break down that vegetation, which could take like 3 years. So I'm curious how you got to that 8 months. The second question, a little bit different. I'm curious when you're looking at some of the water qualities, if you're measuring kind of the TSS, like the total solid something other S, as a kind of throughout the process and understanding how that might kind of ultimately implicate the ash or quality of the final out product.
That's a great question that you have there. That series of questions. So I'm going to do the best and repeat a few of them. So for the water size and the testing of the TDS and the solid suspended, we have to do it on a quarterly base to be complied with our water discharge permit that is required in the state of Florida. So we're monitoring all our disposal water, and we actually have to monitor our incoming water as well because we use well water, and we're required by law to be monitoring all the time. We do pretty good injecting back the water back into the aquifer. So the only thing that's present is a little bit of iron at the moment that we have high elevations of readouts, but it's more recurring on the water itself that we're pulling out than the things we're putting in. So we're doing pretty good on the water management side with the ag film there. Now, the 8 months, I just use that because that's pretty much the turnover when we receive the material starts to decompose, that we can send people out by hand just to clear it out, and then we pull it again and put it back into the system. Unfortunately, we don't have all our 15 acres paved or in concrete, so we have to set it down on sand. So we, little by little, bring it out, and you can see we can receive all types of mulch film. We can use aluminum foil, what we call metallized ag film, and then you got standard, you got white, you got high tunnels, low tunnels, plastic that comes into the facility, and we try to mix everything up together, trying to get the formulation correct on the pellet. So we're mixing everything, and sometimes the resident time on the floor is 8 months, but it can actually vary. It can well go over a year before we get through all that material that came in during that season. To answer your question. What was the other question?
I think that was it. So it sounds like the 8 months is more kind of an operational time span than kind
Yes.
of, okay, cool.
Yes, it's not a written in stone. It's just something that we try to keep it there before a year, so we don't forget that we got it before we intervene with it again. Pretty much.
Cool. I won't need too much time.
Thank you very much. Joe Bork with Broadview Group. Question on your system. What is your throughput capacity?
So that's a great question. The line is actually designed to go with 2 metric tons,
Okay.
but we run it around 50 to 75%, pretty much, because there's a lot of the things, the more you try to push it, it's going to push back in many areas. So we've learned that by taking it at a good, steady pace, you'll be more reliable going through, and you'll have less breakage, because we have a lot of moving parts on the blades and everything, and the more you go, even though we have oversized our shredders and everything, it will start to fold up the material and clump it up, and then your cleaning efficiency, it goes down. So it really has to do with the cleaning efficiency at the end of the day, because you don't want to transport all that sand all the way to your extrusion system. You want to be able to take it out. By having it around 2,000 pounds an hour, it does a great job of cleaning the material.
Is that running 5 days a week, 24 hours a day? Or?
Yes.
Thank you.
Is it possible to use gray water for the cleaning of the bed mulch?
Can you repeat the question?
Is it possible to use gray water? Gray?
Gray water? Yes. So you could use it. Don't recommend it, but it is possible to use it because you're recirculating it. But in our case, we just have the ability to pull out the water through wells, which doesn't cost much in Florida to do, and we just replenish the water as we go through. But to answer your question, yes, you can use gray water.
I don't really have a question. I just want to, for those of you that have been around a fair number of recycle plants, it's pretty rad that someone would show you the inside of their plant in this format. Usually you go inside, you can't take pictures, you can't tell anyone. So secret sauce, thank you, Ishmael, for showing that. That's he's in the nitty gritty. If guys like me and Theron who are collecting this stuff don't have people who are ready to take it, it's a big deal. So I think we've both been to the, you've been to a Bill plant. It's pretty rad. So thanks, man.
Appreciate it. Well, thank you for your time, guys.
Actually,
Have a good one.
real quick.
So we can open it up for, general Q&A session if the panelists want to ask each other questions, or anybody else wants to ask questions of the panelists of Ben and Theron that went previously. Yeah, did you want to ask a question?
Yeah,
Theron?
I got one for Ishmael. Like, Ted said it, hashtag Ted said it. The logistics thing, how much does it really, ballpark cost for you to get it from your facility to an advanced recycler once you have a finished product?
Well, in our case, the logistic cost is it's not that low, but not that expensive, because we are working with a major company, and they control a lot of the logistics that goes in and out. So they have a set price, that they actually charge us through the contract years that we have, and that's going to be stable price for the next 10 years, because that's how we structure our contract with them.
Thank you.
All right. Any more questions? Last chance. Well, I'd just like to thank the panelists for coming here today and presenting to us, and give them a big round of applause. And so just, yeah, that wraps everything up. I just want to remind all of you that the exhibit hall is still happening next door. We have a little break now we're starting our break early, 10 a.m., and we'll be back here at 10:30. Is that right, Gene? Yep. All right, great. So thanks again, everybody.
Thanks, everyone.
All right.
Have a set price for the next.